Okay, now we're going to solve this Stanford Math competition question. We are given that f of x is x minus 1 to the power 4 times x minus 2 to the power 3 times x minus 3 to the power 2. And we want to find the third derivative at 1 plus the third derivative at 2 plus the first derivative at 3. Okay, remember here that we have a product. So here we have this product here of these three functions. Okay, so when we differentiate f, we're going to differentiate this one and we're going to keep these two constant. Okay, and after that we're going to differentiate this one in the middle by keeping this one on the left and this one on the right constant. And after that we're going to differentiate this last one by keeping these two constant. Okay, so the value when we evaluate f, okay, so these coefficients x minus 1, x minus 2, x minus 3, they will go if we do the evaluation or the derivative at least 2 times. So we're going to get rid of this x minus 3 if we differentiate this one twice. Okay, so that means by keeping these two constants. Okay, an easy way to compute is to check this one here. So the derivative of f, the value of the derivative of f at 3, the first derivative. Okay, that means what? So if we want to differentiate this one time, so we're going to differentiate this one here, 4x minus 1 to the power 3 times x minus 2 to the power 3 times x minus 3 to the power 2, plus we're going to keep the first one constant, and we're going to differentiate this one here, x minus 2 to the power 2 times x minus 3 to the power 2, and finally we're going to have 2, it's going to come from here, 2x minus 1 to the power 4 times x minus 2 to the power 3 times x minus 3. Okay, now if we do evaluate at 3, we're going to see that 3 is always here. So 3 minus 3 is 0. So it's going to knock down all of this. The same thing here, it's going to knock down all of these ones. The same thing here, it's going to knock down all these ones. So we're going to have f prime 3 is 0. The same thing for this one here. The second derivative evaluated at 2. This one won't go. This coefficient will stay here. Okay? X minus 2, when we differentiate 2 times, it's going to have x minus 2 to the power 1. And therefore, it's going to stay. When we evaluate, we're going to get f secant of 2 is 0. The same thing for here. This one. The third derivative evaluated at 1. This one, when we differentiate this one 3 times, we're going to have 4 times 3 times 2. It's going to be 24x minus 1. And therefore, times the other coefficients. Okay? And therefore, when we evaluate, we're going to get 0. There are other ones that we missed, the degrees less than 1, but they all will go. So all these factors, they will go. Sorry, x minus 1 to the power 1, x minus 1 to the power 2, x minus 1 to the power 3, and x minus 1 to the power 4. When we plug 1, we're always going to knock down all the others. Okay? And therefore, f third at 1 is 0. And this means that the value of this, the derivative at 1 plus the second derivative at 2 plus the first derivative at 3 is 0. Okay? If you don't like this approach by just expecting or seeing what's next, you can compute the derivative. Exactly. Okay? You can compute that. And you will see that you will get 0. But this one will take longer. Okay? If we had to compute f to the power 4 or the fourth derivative, it would be different. It will be completely different because this power will go. This coefficient x minus 1, which make this one 0, will disappear.